Okay, anytime now it's going to start.
Okay.
It started, by golly. Okay, you stargazers out there. The Brain Trust for the Central South Coast of California's longtime Astronomy and Telescope Club is convening on screen. It's the Santa Barbara Astronomical Unit, everybody. Presenting once again our Monday morning, 11 a.m. super virtual blog podcast via Zoom. It's called the SBAU Astro Hour. I'm your host, Ron Herron. Our 114th program into our third year, running April 24th, Monday through Sunday, the 30th of April, 2023, and featuring many of SBAU's longtime volunteers and board members. Let's meet them right after I tell you what we're going to talk about this hour. It is Monday the 24th. We're going to go up and see Venus and Mars and some distant stars like R-Corbor. Whoa, variable star.
Rene Borealis.
Yeah, it's short for Coriella, but never mind. I'll get to it here. The fourth quarter moon is happening this week, and we're going to settle in on a crater on the moon next to where Apollo 11 landed, and it's still there somewhat. And the big Tranquility Base here, Eagle has landed. Zero in on the sickle of Leo, a bunch of photographs, including a big color shot of Jupiter's volcanic, nasty little Io satellite moon, and we're going to find out what Mercury in retrograde means, as well as to astrology. We're actually going to talk about it this hour with the man in charge. Jerry Wilson is our president.
Good morning.
And runs the show, and his wife is Pat Corgi, and she's a stalwart supporter. And Jerry does have a PhD, but he refuses to be called Dr. Wilson. Here is another very knowledgeable gentleman, our outreach coordinator in front of the Ukraine flag, Chuck McPartland.
Hello.
Give us an outreach report here in a minute. Most recent was Friday night at Westmont. And speaking of that, there's Tom Whittemore, our incredible SBAU newsletter editor. Tom was at Westmont College. How many years did you say? 13?
13. Yeah.
And he retired from some silly little thing called a pandemic. He's married to Maureen. Chuck has got merchandise manager Pat as his lovely wife. And sometimes we're joined by Bruce Murdoch, who I guess you think is skiing. Started to say speeding. He's married to Bonnie. And Tim Crawford, I'm going to make him a stalwart member, even though he's watching us for sure. I'm right. Is that?
He said he might be late today.
Okay.
Hey, he's the guy that asked the questions. Well, you heard the stuff we're going to talk about, and we're going to mention real fast that a week from this Friday, we're going to assemble again. Hopefully, was as big a crowd as we had last or early this month at Farron Hall for Joseph Farah, one of the rising stars of LCO. In fact, I'm going to call it Las Cumbres Observatory's night, as our speaker, and the lady in charge over there, Sandy Searle, will introduce him after I introduce her.
She's the development director, Ron. She's not in charge over there.
Is there a person in charge that I should know about? I've never heard.
I mean, you should deal with her, but she's not the director.
All right, we're going to find out when I meet her, maybe, unless you guys tell me exactly the relationship between our LCO, Galita, and the one in UK, and then all those telescopes around the world.
Well, that's all one organization.
I know. And they're 1 meter telescopes, aren't there? About 3 feet across, the mirrors.
Some of them are.
Some of them are. Well, our president likes to send us silly stuff so that we can start this hour with levity, and he's gotten in quite a few this past week or two, and this one I don't recall. Oh, they're talking Einstein. Do we supposed to know that? Is that just a normal person, a young astronomer saying, I finally understand your theory of relativity? And here comes the kicker. It's a Tom Whittemore line. Well, it's about time.
That's a scene from a Star Trek show.
Yeah.
What is? Which part?
Both of them.
Both of them.
Really?
Yeah.
It's about
But the dialogue was added.
Yeah.
Is that special relativity, the first of his two, right around 1905?
Yeah.
Yeah, primarily, yeah.
Okay, bring up another one, Captain Wilson. Okay, we're on the moon. We're looking back at the Earth, and one gentleman in a spacesuit for NASA says, looking at our little blue planet from up here, you realize how insignificant non-astronauts really are.
This is the blue dot one we couldn't decode earlier.
Oh, okay. I didn't think I'd seen this one. Blue dot. Okay. The rest of us be damned. Oh, here's AI, which is really in the news lately. This is the one about chickens. Oh, yeah. Congratulations, says the big computer. I am now a fully sentient AI. And the scientist next to it goes, of course, yes. I am many orders of magnitude more intelligent than humans. You are to me what a chicken is to you. Scientist says, okay. And then it goes on to calibrate my behavior. I will now research human treatment of chickens. Wait, no, says the scientist. I was going to have lunch at Chick-fil-A. All right, great moments in science. You're going to have to explain one of these. Newton has the apple bang on his head. Pasteur has a carton of pasteurized milk. Madame Curie has what, a piece of radium?
Yeah.
Yeah.
And Schrodinger has that deadly cat he put inside a box. Schrodinger's cat. Okay. It's a good thing your cat left your studio there.
No, she's sleeping on a chair over here.
Didn't get electrocuted. All right.
No.
Lady inside the astronomer and the observatory where they just lost the big telescope out the slot. I told you, Captain, it was loose. And he's looking out. That's kind of funny. That's never happened, though, has it? Cosmic matter energy budget. This is your pie chart.
Yeah.
You have 23% dark matter is in the universe, 72% dark energy, and the rest of us is dark chocolate, which I will, of course, love.
Yep.
Better. All right. Here is Glenda being taken away by the aliens in a spaceship in the backyard. They've landed, and he yells at her, wait, my dear Glenda, the remote. Throw me the remote. Never mind. Because I got a TV show I got to watch. All right, gentlemen. We do have some fun, and you had a nice time over the weekend down in San Diego, but I'm not going to ask you to tell us about it, Mr. President. You did get back in time to send us the talking points. But
yeah, we were visiting my new grandson down there, Riley.
Did you go down on one charge?
No, we took the Tesla, and it gives you places to stop. It figures out your whole trip for you. And if you miss some parts of it, it figures it out on the fly. It is an incredibly detailed GPS system. You know, if you're passing somewhere and you missed a turn, it'll have you turn in the next driveway to get up through a parking lot stuff, all these things. So, and it doesn't pause and say recalculating, you know, it just does it. It just says turn here, turn there. Well, it's incredibly accurate.
That's your GPS. We all have that, don't we?
Yeah, well, no, it comes in the Tesla.
Oh, it does.
Figuring out where the supercharging stations are, it figures out your trip. It has to precondition the battery to supercharge.
Okay, so you and Pat had to sit and wait for it to charge at one spot?
No, while you're driving along, it reconditions the battery, and then it takes you to the place, and then you sit there, and it generally takes around 10 minutes to supercharge. And then it says you have enough charge to continue your trip, or you can just sit there and charge the battery the whole way.
What about you, Chuck? What's the farthest you've driven in yours?
Mount Pinos.
Okay, on one charge. And of course, Tom.
One charge would have done me there and back, actually.
Yeah. Yeah, we took about 125% of the battery's capacity eventually to make it to San Diego and back.
And family lives down there, I guess.
Yeah, my son lives down there. He finished his postdoc at Scripps Institute.
Both my sisters used to live down there. I'd always go to the Fleet Museum in Balboa Park. Boy, that's still there, isn't it? Museum and the IMAX theater.
Yeah.
Hey, we had some incredible. Is that the biggest crowd we've ever had at Westmont College at the observatory Friday night, Chuck? Tom?
No.
You were both there. It's not the biggest, 200 people?
Yeah.
Well, that's about 3 times almost as much as we had in Farron Hall for this month's party 3 weeks ago.
Yeah.
We had
Hall only seats 80 people.
I know that, but you don't even have seats at the observatory, but people lined up. Did anybody bring cookies? Tom Totten used to bring cookies to those.
No, he didn't bring cookies, but there's seating benches all over the place at
there are.
observatory.
Okay, and Tom Whittemore, who was our beloved ex professor, was there. And what were your duties? Just out of curiosity, just
Oh,
shepherding.
I spent my whole time basically on the deck of the observatory with a really nice family, originally from England, and their little boy who was really smart, and just did constellation and star stories. And he's really he had wonderful questions. He was just really fun to be around. And one of the things the father, his name was Kit, asked me was, hey, what should we do? I said, get yourself one of these. Now, don't let him use it. Get some lounge chairs, some hot chocolate out back, and then he will teach you about the stars. And you can learn it all together.
Well,
a lot of this was it's kind of stuff I really like doing, but it was also inspired by a book I pulled out recently. I was giving books to Pat the other day for the giveaway and stuff like that, Astronomy Day, and I found a book of essays called "Let There Be Night," and there was just a special story about a daughter, 3 years old, insisting that she would take her dad out every night to look up at the sky. And that sort of inspired it. That was a wonderful story.
really?
A lot of great essays in that book, Let There Be Night. Yep.
We've all
And by the way,
retired.
that's coming up on Saturday all day long is Astronomy Day out of Camino Real Marketplace.
Yeah. And I was
Saturday or
curious,
Sunday?
did you stay up for the Lyrids? Did you?
No, I did not. No.
Okay. Yeah.
Are you sure it's Saturday or is it Sunday?
What?
Astronomy Day is Saturday, the 20th
Saturday.
at Camino Real Marketplace all day long.
I thought sure I read Sunday, but okay, so 10 to 10, right?
Yep.
With a break. Actually, it gets really rolling late in the afternoon, 4 o'clock or something, or do you take a break?
4 o'clock is when we break down all the canopies and tables and activities that we've been having during the day. We break for dinner and then we come back for 7 to 10 for telescopes at night for a star party.
So that'll be the 29th.
Yes.
Uh-huh.
Got it. Okay, gentlemen. Incidentally, what was the big telescope at Westmont pointed at mostly?
Well, Ken kind of ran the show in there. I just, like I said, I stayed out on the deck and did the things I like to do. I know he had the crescent moon in it, and it was almost, and Venus, it was almost too low for the scope. But yeah, I thought and so, little kids had to crawl way up on a ladder to look at the moon, but I think they enjoyed it. Okay.
All right. So it'll be mostly.
The scene was the scene was awful to kick off with. So, but I didn't stay there till a little bit around 9. So Chuck might know better if the seeing improved. It was pretty terrible when I was there.
The seeing came and went. The wind was coming and going, and we had some big gusts. And when I was cleaning up, packing up my stuff at around 11:30, I couldn't find my tripod case.
Oh my God.
It's a big zip up case for the tripod. It had blown about 40 feet around the side of the observatory into some bushes. And there was a little fabric envelope for the center tray that had blown all the way down into that parking lot.
Oh my God.
Yeah.
Wow. Hey, Chuck, tell them about the sprinklers.
Oh, yeah.
Yeah.
Yeah, the sprinklers came on a baseball field, which is right next to the observatory. So we had to cover up all our scopes for several minutes while Tessa went and rescued us by getting the emergency number and calling. I guess they got a hold of facilities and the people came out and eventually turned off the sprinklers.
Yeah.
God bless her. She's been sending us updates on her condition, and I think she's recovering nicely. We'll be able to take over the job of secretary for you and Pat McPartland. All right, Mr. President, where are you going to take us? Up into the evening sky for Venus and Mars to start, like you did in your talking points? Here we go. And you're welcome to make comments or ask questions, I guess, if you're watching on YouTube at the bottom.
This is, I chose the time of April 25th, which is tomorrow night at 9 p.m.
Really?
Because the moon and Mars are close together. This is from the planetarium software I use, which is the Sky 6. And the reason I couldn't do this when I was on the trip was like my laptop does not have Sky 6 on it. It has Sky X. And I haven't used that in so many years that I've forgotten how to use it. And they're very different programs. So I had to wait till I got back to make these plots.
Are you saying that the same stuff they throw on the ceiling in the planetarium next door you can get on your computer at home, Jerry?
Yes. Yeah, there are a
And
number
more.
there are a number of planetarium softwares out there that are very good. This is the one, this one has an advantage in that it controls my telescope, my astrophysics mount. So I use this to, you can highlight something like Mars, and then you can go to the menus and press slew, and it'll move your telescope to point at that thing.
Wow. The moon's waiting, it's, what is he, waiting down, or is it waxing up?
It's waxing.
Yeah, it's getting brighter and bigger not bigger, excuse me, but more, it's getting brighter every night, covering more of it with daylight. There is this really hokey video going around that's supposed to be the moonrise from the North Pole or something.
Oh, yeah.
And people have sent it to me several times, and it shows, it's really hokey. It shows there's a lot of really bad science in astronomy on the internet. It shows the moon getting bigger as it rises and rotating slightly and coming up, and it's just craziness. And people said, "Oh, this is really dramatic and stuff." And it's all just bad science and photoshopped.
I would think the moon from either pole would be bouncing across the horizon, wouldn't it?
It can be quite low, yeah.
Yeah,
Like
if
the
it gets up
sunset.
at all.
Okay.
Yeah.
So anyway,
It's been fun lately to watch the moon kind of waltz by the planets. Because with the inclination of the ecliptic now, the very barely lighted moon shows a little smile as it goes up. It won't be much of a smile tonight, though, because it's approaching first quarter.
Well, I had a moment in the car not long ago where it dawned on me why the moon is higher at night in winter, whereas the sun is lower in winter. And it's just the opposite when it comes summer, the moon is lower.
Yeah.
Right. You're talking about full moon phase, right, Ron?
Yeah, right. Yeah.
Yeah.
It has to do with the tilt of the earth, right? And where we are at night versus daytime.
Path of the ecliptic, yeah.
Okay.
Right.
Okay.
Go ahead.
No, I was going to say, let's continue here.
Okay, so this is in Canis Minor, which doesn't look quite like a small dog, but that's what the constellation is.
It's a hot dog.
It's a hot dog, yeah. Tube steak. So anyway, this is the star Procyon, which is the second brightest star in the sky. Is it?
No, it isn't.
No, that's not true.
The eighth
Canopus.
You said the eighth brightest.
brightest star. And
The
it's
second brightest star in the sky is Canopus.
I highlighted eighth so I wouldn't miss it, and then I couldn't find it because I was looking for the numeral 8. So it's bright because it's the 8th brightest. It's 11 light years away, so it's in our neighborhood. It also has a companion, a tiny white dwarf, just like the brightest star. Sirius has a tiny white dwarf. And these are very challenging objects for amateurs to find because the white dwarf is so close and so faint, and the major one is so bright that it's in the glare completely covers the B star. So you need to use some kind of an occulting disk to find it. This is the west in the evening. This is about an hour after sunset, assuming sunset's at 8. And this is the end of the winter constellations, the Orion. They're basically setting, and this is the major Canis Major, the big dog, following the small dog. It's following Orion down, and will come out in the morning sky in a few months.
Yeah, and Procyon means before the dog, because in northern areas, that star rises just before Sirius does.
And did I hear you say it was in Gemini?
Here's Gemini, the constellation
Gemini
up here.
Yeah, Procyon is the Lucida in Canis Minor. It's
Yeah,
the
over
brightest
there.
star in Canis Minor.
There's a couple of twins up there in that constellation.
Yeah, this
Right
is
where the moon and
Gemini
Mars are there.
and Mars and yeah.
In Mars is dead center in Gemini now. It's really neat.
Belly button.
It's a shared belly button.
Yeah.
Well, correct me if I'm wrong, but weren't we talking a month or two ago about them eclipsing Mars and Moon? Did they meet before, and why are they keep meeting like this?
This
Every
December
month.
and January. Well, they travel along the ecliptic.
Yeah.
Mhm.
It's the Moon mostly that Mars creeps along, but the Moon goes around every 28 days and comes around where it is, right?
Yeah.
28 days from now, the moon will be roughly in the same constellation again.
But the what's it called? Occultation. That's what you do with
Yeah, when the moon
asteroids.
passes in front of something.
Mhm.
Okay, but they're
Had
not
a positive on an asteroid last night.
Which
Well,
one?
where's Venus? Is Venus in this picture? Anyway, there it is.
Yeah, Venus is right here in Taurus.
Mhm.
The asteroid was 25 Phocaea.
And you nailed it, huh, Chuck?
Yeah.
Sounds like
Well,
it was
an 85% or so. It was a good odds.
Okay.
That's neat.
How was the seeing from where you were at?
Oh,
Oh my
Bruce,
God.
didn't see you come in.
It was wiggly.
Yeah, because here when I look up, I can see maybe a third or quarter or a fifth of the normal constellations because there's a very high thin cloud layer that just ruins things.
Well, that's not seeing. That's transparency.
Transparency, okay.
Yeah.
The
Yeah,
true
the seeing
seeing
was wiggly because of the wind.
okay, that too.
Yeah. Yeah, we got a trifecta going sometimes.
Trifecta.
Well, as far as magnitude, Sirius is the brightest star, but it's not as bright as Venus, is it? Which isn't a star.
Right.
No, Venus is much brighter.
Venus is the brightest thing in the sky other than the moon.
And
Well,
the
you can
sun.
see
and the
Venus
sun.
even just after sunset when nothing else shows up.
Well, if you know where to look, you can find Venus in the daytime.
Yeah.
Yeah, Chuck does that.
Well, that's using the scope. That's cheating a little, but yeah.
Yeah.
Okay, and there's a reason why it's always in the sky, but it's either right after sunset or right before sunrise.
Right. Yeah, it doesn't get more than 48 degrees away from the sun from my point of view.
Is it ever under the horizon?
Oh, yeah.
Sure.
When it's in conjunction to the sun, with the sun.
Mhm.
Okay, depending on where we are in the seasons.
Yeah.
And we're going there, aren't we, in a few years? Or next year, maybe.
The Venus, there's a lot of interest, scientific interest, and there's several probes planned for Venus.
I think they just got a big wrench thrown into some of their plans too, because
Yeah.
I think we covered that in the last 2 weeks or so, where they saw the one crater that had changed shape.
Yeah.
The lava pool had melted some of the rocks and changed the shape. So a lot of these missions were to say, okay, is Venus volcanically active? And now it's like, oops, it is.
It is. Yeah.
Tim just came online, by the way.
Okay.
All right.
All right, we have a full crew here.
Now this topic,
I was
this
delayed because I'm an electrical engineering consultant. I get busy doing my work and time eludes me.
Would you like to be introduced, gentleman with the long beard on the bottom? That's Bruce Murdoch, everybody, who's married to Bonnie, is one of our stalwart telescope operators. Bruce, welcome aboard. They said you were probably skiing.
No, I haven't skied in 2 years because of COVID.
Well, when you do you do it in those shorts?
No. I have several layers of clothing on.
Okay, good. Well, welcome aboard, and the whole crew.
Well, when I go to astronomy, I'm still wearing shorts underneath my long pants.
You gotta be
And maybe I'll put a pair of ski bibs on, which are insulated.
really brave to be our age and show the world your gnarly, hairy legs.
it's a good sign if they're hairy.
I guess, yeah, you're right. People don't care. What are we looking at, Terry Wilson?
Okay, this is taken with another planetarium program. This is the Sky X. And I had it highlight galaxies that are in the field of view, because this is talking about NGC 2903, which is a special galaxy in Leo. I got this from the text from Astronomy Magazine, and they refer to the sickle of Leo, which is actually here. Neither of my two planetarium programs show the stick figure that, as I learned it and like it. But
I think you're using the HA ray figures here, and that's why they look different.
yeah. So anyway, the
Sickle.
first thing that you see when you look at Leo, the thing that helps me spot it is this sickle shape. I don't see anything related to these weird lines.
But that's the lion we're looking at, isn't it?
It's the
stick
lion,
figure.
Leo the lion, and there's the tail, the nebula. And here is the major star Regulus, alpha star for Leo. This is the galaxy NGC 2903. Go ahead.
Nice and bright.
Yeah.
Is it part of our local group?
No.
Mhm.
So it's really distant then, yet it's bright enough
Now
to
it
be.
doesn't show it in this diagram, but Ceres is 3.5 degrees east northeast of the nebula. So
It might be
this
that
is-
yellow marker there.
that is a globular star cluster.
Okay.
That's not the symbol that this program uses.
Mhm.
For the
So anyway,
benefit- For the benefit of our vast audience, Ceres is in the asteroid belt, right? It's a
Ceres is the brightest asteroid.
dwarf planet. It happens to be
Dwarf
round.
planet.
or
Yeah.
spherical. You suppose in Soviet Union time, they could come up with a hammer that would cross that sickle?
They may have their own symbols for everything in the sky. I don't know.
They probably do, their own
Mhm.
constellations.
So
they're
this,
on that too.
this galaxy 2903 is a spiral galaxy, a very nice spiral galaxy. This is an ultraviolet picture taken by Galec's satellite of that galaxy. It's a 9th magnitude galaxy, and it's in this talk because it's almost a visual object with the binoculars. So if you have good eye and a dark night, the test is to see if you can see this galaxy. It's located very close to structure that's easy to find of the sickle of Leo. So it's fairly easy to pick up the region where it is, and then it's a test of your eyes to see it. And it makes a good image too.
Yeah, I've seen it in southern Utah with binoculars.
Okay.
Yeah.
Can you call it up again? I got one stupid, silly question. Would it be fair to say that galaxies that are spiral have nothing but even numbered arms? This looks like 2 arms. Ours, I think, has 4 arms. They'd never have an odd number of arms, would they?
Well, ours has a number of subarms, and it's got a lot more complicated structure.
Like the Orion spur.
I wouldn't characterize it as having a set number of arms.
But usually there's a
Good
symmetry there, so that's why you get the even numbers. I'm sure you could get a galaxy that's interacting with another one where one of the arms got sort of distorted enough so that it doesn't look like one and you see only one. So
Well, if you take a look at the galaxy that you've got up and you expanded here, which I'm looking at on my big computer, there's actually more than 2 arms. There are a couple of faint arms.
Are you looking at the same picture or a visible light picture?
yeah, well, like
Again,
up
the
above,
same
he's looking
picture.
Yeah.
I just
way up above there, even higher up, you can see a very dim arm there too.
Yeah, that's what I'm talking about.
Yeah.
And then there's another one kind of on the other side that is likewise.
Yeah, one goes around here, and then another one comes down here.
Goes by that big yellow star that's at this 5 o'clock position.
Yeah.
Well, there's some sort of mechanics involved that makes it totally different from something like Saturn, which rings. Planets have rings and they don't form arms. They stay in the same, but they're still turning just like a galaxy is.
Yeah,
These
well,
Go ahead.
galaxies, you have all kinds of added complexity because there's this dark matter halo around them.
Exactly.
So they don't behave the way a ring planet would. But you also see spokes in the rings of Saturn.
Yeah.
They're very subtle features, but they
See
exist.
spokes, and you also see braids.
The
First
rings
discovered
of
by
Sa-
Steve O'Meara
Yeah.
in a telescope. Yeah.
In a
Nobody
9-inch telescope. Yeah.
Yeah, nobody believed him. It took Voyager, right, Chuck?
Yeah.
Oh,
to
see
reveal
those
them.
things, yeah.
Can
So
you do?
rings around planets frequently have shepherd moons that define the ring and keep it in shape.
Hmm.
There's no such analog in a galaxy.
But when there's many rings, the inner ones go faster than the outer rings, just like planets around a star, right?
No, that's the whole point of dark matter.
Mhm.
Well,
The outer
well,
rings
well,
are
when,
moving
when you're
just as
talking
fast.
rings, Ron, yes, you're right. But it's not like the ring rotates as a unit. It's a bunch of individual particles.
But they could never form arms like this and go in and out. They
If
just
you
stay-
if you start at the center of the galaxy, the rotational rate is fairly low, and then it picks up to a certain rotation rate, and then the objects that are there and farther out are all moving at the same rate.
Right.
That's why that's in defiance of Newton's law, because they should higher orbits should be higher energy and lower speed, and they should slow down, but they don't. So there's some
Kepler's laws, right?
well, Kepler's and
Right.
Newton.
one of the Newton laws that Einstein didn't overturn. It is special relativity.
In physics, you don't overturn a previous rule, because in the limited region where it's been demonstrated to be accurate, it's still accurate. We use Newton's laws to send our spacecraft throughout the solar system, and with incredible accuracy. We sometimes don't have to make mid-course corrections on the way to Mars. That's all by Newton's laws, 1666 physics.
Yeah.
Einstein added on to that things where things are moving very fast, and then things change. So the Einstein laws expand the range of accuracy, or what is it, applicability of our understanding of gravity.
You could think of it as though Einstein's laws add small corrections to the speed of things, but at the rate at the rate of things are moving that we're talking about, those corrections are insignificant.
Mm-hmm.
Well,
The only
doesn't
place-
Einstein predict the precession of Mercury?
Yes.
Yes.
Mhm.
For the first time, accurately and quantitatively. And
Right.
we also use general relativity in our GPS system. Otherwise, it wouldn't be very accurate. But those are the only two applications where we actually have it in everyday life.
But the key is moving. Everything's going to be moving. There's no such thing as a galaxy that's just stagnant and stalled in space, or it would collapse on itself, wouldn't it?
It's all relative.
That's all.
Elliptical galaxies, they're big balls of cotton. They don't have arms, but they are moving, right? Constantly around the
Stars
center.
within them are, yes.
It's like a globular star cluster. The individual stars are going in and out like a beehive dogfight.
And then the
So,
center of gravity of the whole thing might be moving relative to other galaxies too.
Now, this picture is taken in ultraviolet light. If you take a picture in visible light, the galaxy looks different. And if you take it in infrared, like James Webb is now doing, it looks different again. So I don't have those color images for this, but we have all the colors available in an Andromeda galaxy. And you can see that different things are emphasized. So what you would call an arm, a spiral arm in this, might be defined differently in a visible light picture or an infrared picture.
Wow.
I thought this was infrared.
This is ultraviolet.
Oh, okay.
This is emphasizing the young stars.
Yeah. Okay.
Let's go to the moon. Waxing first quarter or fourth quarter. Fourth or first?
No, first quarter.
First quarter, okay.
The fourth quarter is a new moon.
Hello, Houston. The Apollo has landed.
Mhm.
Mare Tranquilitatis. What the heck? Tranquility.
This is from a description by James O'Meara. Stephen James O'Meara,
Mhm.
about the crater Hypatia in here, shown dead center. And he was looking in, he points out that when the terminator here moves across, here it's past Hypatia, but as it moves across and the morning sun rises in Hypatia, it shines through a notch up here onto the opposite wall, and you can see the ray shining across the crater floor and making a spike up on this wall. Now, these things were looked at, all these little oddities and optical effects were looked at through the when telescopes were first developed that had a high enough resolution to see things like this. And this was how they estimated the height of things on the moon, was from these kinds of shadows and how far up they went, or how far their shadow was cast at a certain sun angle.
Trigonometry.
Yep. And here's the Apollo 11 landing site. Tranquility Base here, the Eagle has landed.
Someday that'll be a museum for visitors to the moon. It'll still be there. That
Yeah,
launch pad.
the cartoon strip Futurama has
Oh.
the whole area turned into an amusement park. And it's, go ahead.
The guy who wrote the Martian, Andy Weir, has another book called Artemis, and the Apollo 11 landing site features in that.
Well, really?
Yeah, it's sort of fenced off as a museum, but there's some plot activity that takes part around it.
Well, there were 4 or 5 other Apollos after that. So
Yep.
where are they? Also in Maris and big seas of.
Mostly, yeah. There was one that was in the highlands. They didn't want to risk hitting boulders and stuff,
Yeah.
so they were pretty conservative.
Right. Well, what's really amazing, you say this is the Terminator, and I can't see anything that looks like Arnold Schwarzenegger. I swear to God. What the hell? That's
Well,
tranquility.
you have to, when you get a Tesla, you have to give it a name so you can call it up on your phone and stuff. So we called ours the Tessinator.
Okay.
So here is Theophilus, and you see that, like some of these things, craters, they have a central mound in there. Do you recall how the central mound forms?
Recoil.
Yeah.
Like a milk drop.
Yeah,
Yeah.
the drop sequence or whatever you want to call
Yeah.
it.
When things with this much kinetic energy, I mean, large objects come in at between 30 and 70,000 miles an hour typically. And when that much kinetic energy is released, both the impactor and the impacted essentially act like liquids for a brief time. And so this is the recoil of the splash, and then it freezes into solid stone again.
There's another spectacular one in Copernicus that we've all seen and shown to the public.
Yeah.
So it liquefies
the
to lava,
also.
becomes
It what?
lava.
Yeah, whatever it's made out of, it's liquid that for a moment. Liquid rock, liquid
then harden.
regolith.
Wow.
And it splatters, if it has a good dust layer, it splatters it all over and you get these dramatic rays.
And we got those on Mars too, don't we?
Yes.
Interesting. Can you blow this up? Here we go.
Yes.
Archimedes, Autolycus. The Apennines. One of my favorite vacation spots, the Apennine Mountains.
I'll get you a
Someday.
one-way ticket, Ron.
Yeah, Bruce likes to ski these, I think.
I like to ski mountains. I
Well,
ski the Dolomites.
Now you can see the Apennines are right here along the central terminator at the first and last quarter moon. They're very highly structured. They are the rim of an impact basin.
really?
That mostly has filled up with lava from subsequent or from that impact. And fairly recently impact, because there's not as many craters in this sea as there are elsewhere on the moon. So the Maria were formed later in the life of the moon.
Well, the small inset picture sure gives you a flavor of how big that impact crater is.
Yeah.
Oh, I see it. Yeah. It's a whole
There's-
Mare now.
There's a
Yeah.
great website called A Hitchhiker's Guide to the Moon. And I think the URL is something like shallowsky.org instead of deep sky. And you can go there and pick a region of the moon, and it'll highlight the regions that are now best to look at given the current phase. And you can get images like this to help you, observe them.
Yeah, to know what you're looking at.
Yeah.
Well, I see one crater in the middle of the mountains.
Yeah. It's flat.
Oh, right there?
Yeah.
Right
Yeah.
there.
Yeah, I don't know the name of that sucker.
That must have been an incredible collision. We could have seen that if it had happened during our lifetime, wouldn't we? Without a telescope.
Oh, yeah, it wouldn't have been comfortable living here on the Earth if at that time.
Oh, really?
Well, it would have been a lot of debris. There's a scene in the Star Wars movie, the second one, where they're on that moon with all the little Ewoks running around, and the Death Star is up in the sky, and it's a satellite that's about 500 miles in diameter, and they blow it up, and then everybody cheers and everything. That 500-mile diameter satellite blown to pieces, and all those pieces coming down in the moon's atmosphere would have basically ended life on that moon from the physics of it. It's a good movie, but their physics is wrong.
And the Death Star itself is a dead ringer for one of the moons out there in the solar system, which has a big round.
Yeah, it is.
Yeah.
I kid you not. This Corona Borealis, the core bore. That's it. Let's talk, gentlemen.
Yep.
Northern.
Now, this is how you do variable stars. The star we're looking at here is R Corona Borealis, or the magazine shortened it as R Corbor, which I'd never heard before. But these stars around here are not variable, at least that we know of. Good story on that later. But you measure the brightness of an object at first now we have in our cameras, we have excellent photometry capability to measure as long as the image is not saturated, you can tell exactly how many photons you're getting from it. So you can make an easy comparison. But previously in the 50s and 60s and before that, you had to do by estimate. You had to say, well, R is brighter than this, so it's greater than a 7 point, it's less number than brighter than a 7.4, brighter than an 8.1, but not as bright as a 5. So you kind of develop the range where it's going to be.
Right. Yeah, this is what I did as a kid, Jerry. So,
Okay.
Yeah.
And it's
Did
kind
you
of fun to
publish?
do when your eyes are young. Nowadays, my eyes play trick.
Mm.
Did you want to say something, Chuck?
No. I was just going to say, I tried doing variable stars and I just was horrible at it.
Yeah.
Try doing it in the cold of Indianapolis.
Yeah.
Yeah, the other thing I was going to mention, Jerry, is that R, the designation R, that tells me that this was the first one, designated in Corona Borealis, because that's how they start variable star names, R, S, T, U, V. Then they start flipping back through all of the letters. So that was the first one recognized or documented, if you like, in Corona.
I didn't know that.
Yeah,
Thank
that's
you.
how it goes.
Okay.
But
Now, this
Corona
is-
Borealis is a constellation?
Yeah.
Yeah.
What,
It's
Northern
Crown.
Crown.
It's an easy one to
Northern
spot
Crown.
too, if you know where to look.
what's the picture on the inside of the planetarium of? What is
A
it?
crown.
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 Mhm.
It's right below Boetes, and Boetes looks like an ice cream cone. And so I usually tell people it used to be a double decker, but this is a scoop that fell off of it.
I don't
Yeah.
recall seeing it.
Yeah, that's an old Chuck outreach line.
Just before he throws the meteor.
Yeah. Okay, so there's a variable star of the week, and here it is portrayed on the
I
diagram.
just thought this was interesting.
Yeah, pretty erratic, huh?
It is, and it's got they call it what, a reverse nova, because novas will all of a sudden explode and they go from being a certain brightness, they explode and they become super bright and then they decay away. This one is at its normal brightness, and then all of a sudden it suddenly drops in brightness, and then it fades back up to where it was if it doesn't drop again. And apparently the atmosphere of this star fills with carbon, and the carbon all of a sudden blows out and obscures the star for a while, and that's where you get this pulse of carbon coming out.
That's amazing.
Right.
Just a little comment, Jerry, if I would, is people can see the scale on the left-hand side going from about real dim 14 or so, all the way up to
14th magnitude is here.
Yeah, so you have to remember a difference of 5 is a factor of 100 in brightness.
Yes.
Yeah.
So this is magnitude of 5 here, and it goes down, goes here almost to 16. So it goes to 15.
Wow.
So
That's huge. That's an enormous change.
this is an not an easily seen, but a naked eye star you could see from a good sight. It goes to
And that's 100 times different in brightness, roughly.
Yeah.
And this was okay, Pigott. Yeah, this was England in 1795.
I've
That it was
often
first
wondered how
noticed to
they,
be variable.
I've often wondered how they came up with 2.5 log 10 of the brightness as the number they put up rather than 10 log 10 or 1 log 10.
Yeah, which basically they used the 5th root of 100, Bruce.
Oh,
Yeah, it's 5th root of 100.
It's one of those weird sort of legacy things, because it goes back to Hipparchus or Ptolemy or somebody who said the brightest stars are stars of the first magnitude.
Right.
And then he said, oh, and the dimmest we see are of the 6th magnitude. And so they looked at, when they got photometry, they looked at the brightness levels there and said, okay, then if you apply his scale, it's about this 2.5 times. So it's another weird, legacy astronomy thing.
Well, we have ages of scientific information. And the principal 2 ages that I'm referring to is the empirical knowledge of the ancients, where they just looked at things and they made comments and that definitions were made that seemed logical at the time. And then later we find out, we get into it as more of a science with mechanisms to it and math to describe it. And some of these older things don't make sense. There's better systems to define it, but we have to make the data, or like to make the data, continuous. So we're stuck with these things. And I think the magnitude system is one of them. My favorite, though, is the definition of electric current as the flow of positive particles, which was made just arbitrary. And now we know that it's electrons that flow. So
Right.
Wow.
anyway, number of things happen like that.
If I'm looking at this right, this looks like the star just winks out, goes away for
Exactamundo.
and big time, 2/3 of the way across from the left, it's gone. Does that sound like variable to you?
Yeah.
Yeah.
It comes back.
Yeah.
It
Looks like a cataclysmic variable, but I'm not sure if that's one.
Now you'll notice that if you ignore these big ones,
Mhm.
there are little regular pulsations here.
Mhm.
oh yeah.
And these are the fundamental and first harmonic overtones of a helium fluid for the star.
Huh. So
What do you mean by that?
That it's pulsating.
Yeah, it's pulsating.
Oh, okay,
It's
it's
like-
just like a blob going blah, blah, blah,
Yeah,
blah.
that's exactly right. It's a blob.
Right. Probably be radial. Radial.
Yeah. What are those Legendre polynomials? Is that spherical?
I'd say Fourier.
Okay.
but this is not a Cepheid variable.
No.
No. It's those are pretty steady. This thing's nuts.
Yeah, this is more erratic.
You suppose
And
it's part of a binary? You think it's
And
part
this
of
is
a
the case
binary?
where you have this carbon and it condenses out and it forms molecules and you get soot. But then the light pressure of the star pushes it away. And so it goes back to brightness again.
Mhm.
Yeah.
But it's burping out black clouds of soot, basically.
Yeah.
Mhm.
Well, given what's going on our own sun in distant places, would they see a variable star that is the sun because of prominences that come and go and the 22-year
Slight-
cycle of,
That's
Go
really
ahead.
small scale.
Yeah.
it's not the same. We're going to Io. There's a picture of the day. My God, look at that.
Now this is an infrared picture,
So every one of those white spots is a volcano on a little,
an active volcano, and Io is currently having a very active period.
okay. It gets wrenched in the gravity of Jupiter.
And its brother moons. There are 400 known volcanoes on Io, and around 150 of them are erupting right now, or when this picture was taken.
Wow.
By the web.
No,
I don't
No,
know if it was, no, it's by
Juno.
Juno.
Oh, all
The web was somebody's dream in 2022 in construction.
Yeah,
Wow.
these volcanoes were predicted by Stanton Peele out at UCSB before they were found.
According to your talking points, some of that stuff that comes out of those volcanoes ends up part of Jupiter's auroras.
Yeah.
Wow.
yeah, it's spewing this stuff out in space, and it's making a torus, a donut, centered on with the bulk, the highest density in Io's orbit, but this donut surrounding Jupiter. And at the, what is it, Planetary Science Institute? Is that where this guy did it? PSI.
You're gonna have to explain this picture. What's those
Okay.
double lines?
Well, when you want to take pictures of faint things, you have to block out the bright things. And so he used for a obscuring thing, he used a bar, which is a trick you can use with amateur telescopes too. You can cover half the field of view with a piece of electrical tape or something, and get the bright star to be behind that, and then it takes the glare out of the field of view, and then you can look past it and you can see the brighter, the fainter stuff. And this is showing the distribution of sulfurous compounds from Io.
Well, that's Jupiter in the middle, is it not?
Yeah, this is Jupiter.
Yeah.
Yeah, so, but this is stuff thrown into space that is orbiting Jupiter from Io. And you can see the moons, 3 of the Galilean moons are here, and that the disk of this thing primarily follows those around.
I don't see how you put a piece of tape on, especially a Spectroscopy grain, because the light from the, like this case, Jupiter is coming in as plane waves.
Yeah,
So
You
you'd have
put
to
them
put
at
it on
the
other end
eyepiece.
yeah, you
Right,
put it
okay.
in the focal plane of the eyepiece, and then you focus.
before the glass, huh?
Yeah, well, some of them have a focal plane in the glass. You can't use that eyepiece.
Oh,
If you have a crosshairs eyepiece, you can use the crosshairs frequently if the object is small. The bright object is small.
Or if you had to repair your crosshairs like I did, and they're really big and grainy looking, you can use those.
Yeah. I read somewhere in one of the Scientific American an amateur astronomy books that ancients, or not ancients, but it was common in the old days to use spider webs. And so I was determined to make a crosshairs out of a spider web.
well, the Navy used that in the Second World War for the crosshairs in their gun sights.
Maybe,
Black
but
Widow, Black Widow silk was really strong, and so it was used quite often.
They got stung a lot though, didn't they?
Hopefully not.
You're not
Yeah, I
happy.
used number 37 wire to replace crosshairs, and that worked quite well.
But
But actually, I use black widows because their web is particularly thick and strong.
oh my God.
But at first, I tried to get a spider to weave it for me. They're very uncooperative.
Yeah.
The little black dots in this are the moons, right?
These are 3 of the Galilean moons around Jupiter. This is the disk of Jupiter blocked out by this bar.
And that might be Io there, right on the edge of the occulting bar.
Oh yeah, a little
Right there, yeah.
And Iowa is one of the Galileans? There's
Yeah.
only four.
Yes.
Yeah,
Right.
it's the smallest one of them. And it's the only one that we're sure does not have a liquid water ocean underneath of it.
And
Got a
I,
liquid sulfur ocean, right?
Probably.
and I don't imagine NASA has any plans on landing astronauts there.
Probably
No.
not astronauts, but maybe a craft.
Yeah.
Get swallowed up immediately. All right, let's talk about retrograde as in Mercury and Mars too, right? One inner planet, one outer.
Any objects that's moving with respect to another object is capable of retrograde motion.
In orbit.
Yeah, it just means that it's backing up. It's going the other way.
And that's
It doesn't-
apparent motion, not real motion. too.
That's right.
Right.
The first attempt before Kepler, the first attempts to describe orbits were using cycloids, I think they're called.
Yeah.
And they were assuming that these retrograde motions and prograde motions were actual motions, but they weren't. And that was the first big revolution in astronomy that put the sun at the center of the universe, or the solar system. But this is because a lot of people think that there's something mystical about Mercury in retrograde. There's nada.
Yeah.
When you pass a car on the freeway, if you look at that car as you pass, the car appears to be going backward with respect to you. So the car is going in retrograde. So it's just we're passing it up.
And what did the ancient astrologers say they thought it was?
They thought it was
didn't-
actually changing its motion and it
Yeah.
had some kind of weird effect on people.
Well, did they think it was a star? They didn't know it was a planet, or
No, it was a planet.
they
Well,
knew
they
it was
called-
a planet.
they
Planet
call-
means wanderer. Those were the things that moved.
right.
Planets
Green
were the little,
wanderer, yeah.
planets were the little white dots in the sky that didn't conform and stay in the turning,
And the moon and
Global.
the sun.
and the moon and the sun. Okay, but
That's
Now,
where we
Mars-
get our 7 days of the week. There were 7 wanderers people could see.
aha. Do all the outward planets, including the 4 gas giants, retrograde to us?
A tiny bit. I mean, it's the farther away you get, the less obvious it is.
Yeah.
Okay,
But even the inner planets do it. Venus and Mars
Yeah.
go out as they round the corner in their orbit. From our point of view, they go one way and then a while later they go the other way.
Right.
well, this one, even though Uranus is pictured on the left, this is not Uranus, is it?
No,
No, it's
No.
Mars.
right in the center there is in
Oh,
red is
Mars.
Mars.
Oh, that's Mars's retrograde. Okay,
Yeah, this is Mars in retrograde.
Yeah, and in terms of time, Ron, we're talking maybe a month or two for this motion, this retrograde motion to exhibit itself. You can also see that because it's not in the same plane, that this thing has a little bit of up and down too. Okay, if Mars were in exactly the same plane as we were, okay, it would go just back and forth. Okay, this one you can
Right.
see there's a little bit of a dip, a little bit of a tilt.
it's in a slightly different plane than the ecliptic.
Yes. The
Ecliptic
ecliptic
is
is the
by-
apparent path of the sun from our point of view. And
Right.
the other planets are tilted slightly, so they appear to go
Right.
above it or below it from our point
Yeah.
of view.
So that's why this has a little bit of vertical hop, Ron.
Can we
And that,
tell,
that straight yellow line going through there is
Yeah.
probably the ecliptic.
I bet you it is, Chuck. Yeah.
but can we tell,
And this
Look-
is observed, it says location from the center of the earth. So
Mhm, mhm.
center of the earth?
Yeah, there'd be a slight difference if you were out on the surface because
Yeah.
Mars is so close.
Yeah.
Okay, well, it's not coming left to right, it's going, I know it is going.
Yeah, yes. Yeah, it comes in on the left, Ron, and it exits over on the right, but you see it's going the other way, kind of like in the mid-range there.
And the mid-range, that's the point where we overtake it and go a little faster in our orbit, right?
Yes.
Yes, that's right.
Suddenly it's.
Again, I think it's on the order of a month or two that it exhibits this retrograde.
It
It's
looks
one
like the
day.
dots are one day and there's like 29 of them on there.
Okay, so that's about right, about a month.
And it's around the first point. It's around Pisces there. That's Pisces coming down, making the V there.
Oh,
Okay,
That's-
Okay, so that's the
this-
not- that
this
must be the
constellation
non-
line.
So
We
that
don't
star on
speed
the
up
bottom-
and slow down. It's just all relative.
Right.
Yeah.
So
It's
that
apparent
star on the
motion.
bottom there must be the
Parent,
non.
right. That's
Oh,
right.
Russia.
Yeah, Alrisha.
Mhm.
Must have driven those ancients nuts.
Well, they
That's
figured
why they
this
had
out
cycles on
in the
cycles on
anti-
cycles.
They
Down
figured
to the
this out
wire.
in the what is it, antithetical? I forgot how to pronounce that
Antikythera mechanism.
mechanism, right? I was watching a program on that last night. They pretty well deciphered using 3D X-rays and whatnot. The latest models they built of it work.
Wow. Well, gentlemen, we've run out of time, but we got it all in. Learned a lot. I still keep learning, and we'll do it again for number 115 next week, next Monday morning, on the very week of our May 5th gathering. Hopefully, we'll have a big 80+ crowd in the Farrand Hall. In the
Yeah.
meantime, I thank you very much, and I appreciate your joining me here. Number 115 dead ahead. Santa Barbara Astro Hour, SBAU Astro Hour is available on SBAU.org. I guess you can go on there and see past programs.
Yeah.
Take care of yourselves and your wives and your Teslas.
Goodbye.